Today we're going to move on to section 5.1, verifying trigonometric identities. So first we want to just review what an identity is. So an identity is an equation, so that means it has an equal bar, okay? That is true for all variables. So if we look at the expression 2 times the quantity x minus 1, using the distributive property, we get 2x minus 1. This is an identity because any variable, any value of x that we put in here, it's still going to be true. The same for sine x equals sine x of the quantity x plus 2 pi, right? We talked about how sine was periodic with a period of 2 pi. So if we start, say, at pi over 4 on our unit circle, and we go around 2 pi, we're going to be back at that same sine value. Okay, so that's an identity. Similarly, one of our even and odd properties, okay, sine is an even function. So if we take the sine of the negative x, it's going to be equal to the negative sine of x. So those are all our identities. We know that they are true for all values of x. When you are verifying identities, it's going to be really important that you realize they can be manipulated. So manipulated means changed algebraically, okay, using properties that are allowed to get something that's equivalent. Okay, so I think that you all will remember the Pythagorean identity sine squared of x plus cosine squared of x equals 1. I just want to show you, if we were to subtract cosine squared of x from both sides, we would get sine squared of x equals 1 minus the cosine squared of x. Okay, those are going to be equivalent. We just manipulated this equation a little bit by subtracting cosine squared x from both sides. Similarly, if we start with this top line and we subtracted sine squared x from both sides, we would get cosine squared of x equals 1 minus sine squared of x. These two equations are still Pythagorean identities, okay? They're equivalent to this top equation. They just look a little different. I can never remember the Pythagorean identities that involve tangent and secant and cotangent and cosecant. I never, ever, ever have got them to stick in my head. So what I do is when I'm on a quiz or a test or whenever I need to use them, I start with my Pythagorean identity and I think, okay, if I divide by sine, everything by sine squared, I'm going to get 1 plus cosine over sine is cotangent, and 1 over sine is cosecant. Okay, and this can be manipulated the same way. We can, if we subtract 1 from both sides, we can see that cotangent squared of x is equal to cosecant squared x minus 1. Okay, and there are other ways to manipulate this as well. Okay, so I divided both sides by sine squared of x. Now I'm going to divide both sides by cosine squared of x. So sine squared over cosine squared is going to give me tangent squared. Cosine squared over cosine squared is going to give me a plus 1. And 1 over cosine squared is going to give me the secant squared of x. Okay, so if I wanted to see what this 1 was equal to, I could say 1 is equal to, I'm going to subtract tangent squared from both sides. Okay, so that's a way to manipulate my identity, but still have something that's always equal to each other. For my reciprocal identities, okay, hopefully you remember that the cosecant is equal to 1 over the sine. You need to realize that you might also need to recognize that the sine is equal to 1 over the cosecant. And you might also, if you multiply both sides, see that the sine of x times the cosecant of x is equal to 1. Similarly, you might need to recognize that the cosine is the reciprocal of the secant. And using the same logic as before, cosine x times secant x. Any reciprocal multiplied by it, anything multiplied by its reciprocal is always equal to 1. Okay, and same, tangent of x is equal to 1 over the cotangent of x. Okay, and if we multiply it by both sides, we'll see that tangent of x times cotangent of x is going to be equal to 1. Okay, these are all identities. They're just written in different ways. And then finally, you want to keep track of and remember that there are the even and odd identities. So anytime you see a negative argument, you might want to use those identities. Okay, so we are going to work on verifying our first identity. So to verify an identity just means to show that the left side of the equation simplifies to the same thing as the right side of the equation. And you can actually start on either side of the equation. What you usually want to do is you want to look for the side that's most complicated. Okay, so here hopefully you can see in problem A that we have 2 functions on the left and we only have 1 function on the right. So I'm going to start and I'm just going to rewrite. Sorry about that. The expression that I have on the left. And now I want to see if I can get that to be equal to the cotangent of x. So I know one of my first strategies is just to try to write everything over in terms of cosines and sines, and then see if I can get it to be equal to each other. So cosine is already in terms of cosine. And cosecant, I'm going to use my reciprocal property and remember that that is 1 over the sine of x. Couple things here. One of the most common mistakes that students make is that they forget their argument. Okay, so they might write cosine times 1 over sine. Okay, the argument is really important because as these get more complicated, you might have different variables as your arguments. Okay, so the solution process could be really different. So it's really important that you have your argument in for both. And so I am going to just multiply fractions. I multiply the numerator. I get cosine x over 1 times sine of x is sine of x. And then I recognize that the cosine x over the sine of x is equal to the cotangent of x. And I always put a check to show that I verified the identity. Okay, so important thing, you want to have whatever side you're starting with over here, your equal bars should line up and you should have empty space on one side. Okay, this is a formatting issue. I'm going to be a stickler for it because it's not hard, but it needs to look like this. People start writing things all over the place. This is sort of, if you think about APA or MLA citations and sort of the rules for that, this is similar in math. When you verify identities, you put your starting expression on the left, your equal bars should line up, and your ending expression should be on the bottom right. Okay, let's try our next one. So I have the cotangent of negative x times the sine of x equals the negative cosine of x. And I want to prove this identity. So I am looking and I see again my left-hand side looks more complicated. So I'm going to say the cotangent of negative x times the sine of x. All I'm doing is rewriting that equals. So that was my more complicated side. I see that I have a negative argument. So that is a clue to me that I want to rewrite this. Okay, and I remember that cotangent is an even function. And I remember that this is equal to cotangent of x sine x. So that didn't really get me where I needed to be. So my next strategy is usually to write over in terms of sine and cosine. So my negative stays there. Cotangent is the cosine of x over the sine of x by definition times the sine of x. Okay, I'm going to put this over 1. And I can see that my sine of x is going to divide out, and I'm left with negative cosine of x, which is what I wanted to end up with. So now I verified that identity. For our next one, again, I notice that the left is more complicated. So I'm going to write that over, being careful to copy it exactly and make sure I have all of my arguments. And I am going to use this fact. If you have a fraction a plus b over c, that's equivalent to a over c plus b over c. Okay, so I'm just going to split my fraction. So I get tan x over sine x. Okay, so that's the first, what came before the plus sign over the denominator, plus what came after the plus sign over the denominator. Okay, I can see that sine x over sine x is plus 1. And that looks to me like I'm in a pretty good place because I have the plus 1 from there. I'm still am kind of stuck with my tan x over sine x. So I am going to rewrite in terms of sine and cosine. So tangent is sine of x over cosine of x over sine of x. Okay, if you can see right away that this is going to be equal to 1 over cosine of x, you can go right there. If you don't see that, you are rewriting this as sine of x over cosine of x times 1 over sine of x. Okay, we're dividing by sine of x, so that means we're multiplying by the reciprocal. So my sine of x and sine of x divide out. I'm left with 1 over cosine x plus 1. And I remember that 1 over cosine of x is equal to the secant of x plus 1. So now I came back to where I wanted to be, and I showed that both sides are equal. Okay, again, quickly formatting. My starting point, my equal bars are all lined up, my ending point, and a check. For letter D, I noticed that my left side is more complicated, so I'm rewriting that side. I'm going to put my equal sign down here because I can see that I'm not going to fit here, so that's okay to do. So I noticed that both of these have a cosecant in them. So I am going to factor out that cosecant. And I end up with the cosecant, I would need to do 1 minus cosine squared of x. So I get the cosecant of x, and then 1 minus cosine squared of x. If I look back at my Pythagorean theorem identities, I can see manipulated 1 minus cosine squared of x is equal to sine squared of x. So I am going to replace my 1 minus cosine squared of x with sine squared of x. And then I am going to notice that this is cosecant of x times sine of x times sine of x. Okay, because sine squared is sine of x times sine of x. And then I notice cosecant of x times sine of x is equal to 1. Okay, because those are reciprocals. So multiplying together, we get 1. And so this is equal to the sine of x. Okay, which is the same as what I wanted to end up with up here. So I put my check mark. I check my formatting real quick. Okay, and it looks good. Please watch part 2.